of course, we also need a UI and a game over state and scoring and break the blocks and have them fall down. And there are several other, things we can add to the game, like in the real Lumines on the left-hand side, almost like in Tetris, where you have a list of what's coming next. So you have your current block overhead, dropping it down into the gameplay area. And on the left-hand side of the UI, you have 3 boxes that show you the next 3 quads you're going to be receiving to add to the gameplay area. That's obviously incredibly helpful for planning ahead to set up combos and everything. So we can add a queue system to have the next 3 quads spawned in advance and then drop into the queue and become our current quad. That won't take all that long, and that's a fun addition to add some gameplay depth and strategy. But for now, we'll just focus on highlighting the blocks and then clearing them and dropping down blocks. That's still plenty of gameplay logic before we add on all the bells and whistles. So, when the timer bar overlaps a block, we probably want to set up like some sort of switch statement. So if we had, 5 or 6 or 7 or more things that the timer bar could overlap with and interact with, we obviously wouldn't want a huge chain of branches. But I think the only 2 things we're going to interact with are block actors and the grid collision box. So I think this is probably fine to just have a branch here. So if what we overlapped with was a block, so let's say get class of the other actor that we overlapped with, and if the class is of type block PP, then we will cast it to block PP. I guess we'll say is valid, just to make sure we get everything in order. So we're saying if the actor that we're overlapping right now is valid and is of the block BP class, then we will cast it to block PP. And we're going to check its state, so we'll say get my state. And if its state is matched, then we want to turn it into highlighted. So if state is equal to matched, then we'll create a function to become highlighted. And if the actor we overlapped is not block BP or invalid, then check and see if it's got a component of the grid collision box type. So this will be a little bit funky, but I'm going to do this again where I have a weird loop thing like that. So let's quickly go into the block, and we can probably sort of duplicate the logic here we have for become matched and make a become highlighted function. And so become matched, we set our state to matched and we do a transition. So we'll do another transition very similar to this one, where we go from matched to highlighted. And I was checking the gameplay videos of Lumines, and the highlighted blocks always look the same no matter whether it's color 0 or color 1. So we'll just have one material for, highlighted. So we'll go ahead and make that now. This a cascading list of tasks that I'm performing right now, but I think it's relatively clear why I'm doing what I'm doing, hopefully. So the highlighted state in the Lumines game, everything kind of turns into like a chrome look where it's very shiny and silver, and we'll go ahead and do that, I guess. But sort of a darker silver than this, if that makes any sense. I want it to be a material instance. It doesn't really matter whether it's from color 0 or color 1. I'll go ahead and do this one, I guess, just to make a material instance from here and call it block highlighted matte inst. And it's going to be dark silver. Now, it does need to inherit from the same class in order to do the interpolation. So I think actually I need to make one for both color 0 and color 1, even though it's going to look exactly the same. So I also need to expose more parameters on the materials so that I can use a specular change. Or even a metallic value so that it becomes more metallic looking like it does in the real game. So let's add some more parameters here. Call this metallic param. Oops, that is not the right place I wanted to put that. I want to convert this to a parameter and then change the name to metallic param. And I think this defaults to 0.5 maybe. Let's see if this changes it, and if it does, I can't tell. I think it's fine. So if I change this to, 0.8, it's probably going to look a lot more shiny and weird and metallic, so that's good. That's what we want for the highlighted state, not any other state though. So we need to add the same parameter to the color 1 as well. And now, when we make these sibling material instances, block color 0, highlighted, inst. Now, to reiterate, I need to make, even though I intend to make the color exactly the same for both of these highlighted instances, there needs to be a child of both the initial parent types, because for interpolation they need to come from the same material. The current instance and the target instance need to be the same material. So that's why I'm doing this. Block color 0, color 1, highlighted, instance. Capital I there just for consistency. Save all. Now we're going to set the metallic parameter to something like 0.9 and change the base and emissive colors to a sort of silvery gray, gunmetal gray. Or we can even just turn the emissive off. That might be fine too. See how that looks. Maybe a slight emissive value. Just going to copy this value so I have it to copy to the other slots. Maybe something like 10 instead of 30 or what? Oh, no. Okay, maybe something like 0.5 or 0.2, just so that they glow a little bit. I think they'll already glow from the directional light reflecting off of their metallic surface, but we'll see. So now I'll just do the same for color 1, highlighted inst. Paste my value in there again. Is that correct? Okay. 0.2, is that what I said? Yeah, okay, that's the same. Now back to the block finally, and when we transition from matched, so let's make a custom event, color transition matched to highlighted. We can copy pretty much all of this logic, including the timeline. All we're going to be changing is the values here, basically. So there may be a better way to parameterize this so we don't have all this repeat logic. So for color 1, we set the target to block color 1 highlighted and block color 0 highlighted. And that's it. So, if you want to go ahead and try to parameterize this one, or just parameterize these so that based on whether it's this event or that event, you set these and then run the same logic. I may come back and do that later, but for now I'm just going to move on to adding more functionality to the game. This is a very minor optimization for, consistency that you can make for better, extensibility, I should say. So now we want to go back to the become highlighted function and make sure we do the same thing we did here. So set the material to highlighted, or set the state to highlighted, sorry, and then run the color transition event matched to highlighted. And we'll see how that looks, if it works. We'll probably need to do something else, but let's just see if that works. And now that passes through and does not highlight them. So clearly we're forgetting something. And that something is most likely actually calling the become highlighted function. So on the timer bar, if it is matched, the block that we just touched, let's make it become highlighted. Like so. Oops. That's a handy blueprint shortcut. You can just double click on any function like this and it'll take you to the blueprint that contains that function. A nice way to maneuver around if you don't have all your tabs open at once like this. So that should make the change actually happen. And there we go, it's turning gray, which is not quite as metallic looking as I had hoped. Let's get a closer look at that. It does catch the light perhaps a little differently, but we can also maybe increase the specularity, or we might need to add some sort of texture to the material so that it looks more interesting, I guess, than that. or a gradient of some sort. In Lumines, there's a sort of gradient where it's like darker in the middle and brighter on the edges or something. It looks visually distinct from the other types of tiles. So let's try to do something to spruce up the visual a little bit here. We can go back to the parent materials and add a specular parameter. So they're really matte without that at all. And then when you turn it to something high like 1, then it's very shiny. Not all that different from 0.5 to 1, I suppose. Add it to both and check real quick what it looks like. So if we go to the highlighted and change these values, I guess when it's metallic, it doesn't make as big of a difference. Since this texture is only on a cube shape, it's not really going to make that big of an impact. Unless the camera is moving around so you can catch the light at different angles. So to further differentiate the highlighted from the unmatched and the matched, let's also add a roughness parameter, just like the other two we've added, to make it even smoother looking when it's highlighted like a metallic surface. And hopefully that'll give it some distinction. I think 0.5 is the default for roughness too. Maybe. And that'll be the same for unmatched and highlighted, or matched and unmatched. And then for highlighted, let's lower that value to something like 0.1, or even let's just try 0. Yeah, wow, okay. Now the problem is there's nothing to reflect in our scene because there's no skybox or anything but the directional light. So we'll see what that looks like in the game, but hopefully it does something. Yeah, see, it's just reflecting the nothing around it, so it doesn't even look any different than before, or not much different. But if we eject, maybe we can see more of the, yeah, see, it's a much stronger reflection of the directional light. So if we reorient the directional light, it might be visible from the camera's perspective. I can just like add a cube and give it this material, maybe. And then I'm going to go ahead and build lighting, which I haven't even done yet. So if I go to lighting quality, I'm going to put it on high and then build lighting only. That'll take 10 seconds to a minute, or 10 minutes or an hour based on how complex your scene is, but this should be relatively quick since our scene is just one object. And now I'm going to try to reorient. I'm going to first pin the camera view so I can see what the camera sees in game. And I'm going to move the cube closer to the camera for now. That won't have any effect because it's orthographic projection. So I'm just going to build lighting again since I moved the cube around. And then I'm going to move the directional light, rotate its direction so that I can see if that has an effect on the lighting of the cube. And really the only way we're going to get a metallic look, I think, to this cube is to, well, we have to not move the directional light too much, otherwise the rest of the scene will look worse. But we can give some sort of roughness to the texture. And the only way I can think to do that is to, well, we can try other things too. We can also add point lights that, you know, give off complex light in 3 dimensions. Then they'll have something more interesting to play off of. We will need to change the settings on this point light to not drop off so quickly. So if we turn off the inverse squared thing and turn off our light drop off, or maybe turn up the intensity to see if this is even having an effect on this cube at all. Doesn't seem to be. Well, there's the problem. It is having an effect, but it's a cube with really flat edges, so like it's not very pronounced. You know what we can and will do is I'm gonna make these. I'm gonna make a model in Blender, I think, that is like a cube with somewhere between a cube and a sphere, you know, so that it's like a rounded edges cube. Okay, so after a bit of messing around in Blender, I managed to figure out how to make a curved cube. It's a bit like a sphere, but mostly a cube. And I'll go ahead and walk you through how I did it in Blender. I'm not experienced with Blender by any means, but I need to give credit to Brand Lee C is the name of the YouTube account. I watched a YouTube video that showed me how to do this, so I will link that YouTube video in the description of this video if I remember. But if not, the video is called Blender Tutorial Transforming / Morphing Cube to Sphere. So it's a very simple 2-minute video. We're only going to use the first like minute of that video, but I'll quickly go through how I did it in Blender. So now we will open up Blender, and I'm going to just delete the camera and lamp here by right-clicking on them and selecting delete with the X key on the keyboard. And then I'm going to click on the cube, and this isn't going to be a Blender tutorial, so if you don't know how to use Blender, don't worry about it. This is just a minor thing, but I'll try to walk you through it. It's free software. It's immensely powerful, and it's really cool, so a bit intimidating at first. But anyway, we're going to go to the vertex data options here, and then go to shape keys, add a new shape key, and just leave that one alone, add another one, and we'll left click twice here and rename this to, I'm just going to call it sphere key, and then we're going to go into edit mode on the object, this cube that we have selected, and go to subdivide, and I'm just going to add 10 cuts, but you know, whatever you think seems enough to make a shape that you think is good. And then we're going to go down to the mesh options here, go to transform to sphere, and then that is a modifier that allows us to drag the mouse and change how much we want this to look like a sphere. I just did something around here, or even less than that, just minor edges to make it have a little bit of 3D shape to it, so that it'll hopefully catch the light more interestingly in our game and show that it has a metallic-like surface. So, you know, you can do whatever you think feels right there. And then we need to go back into object mode and confirm that the values are working properly. When we move the value from the shape key from 0 to 1, it becomes more like a sphere. I think these faces that you can see here look like a bunch of little squares. I think those will be, you know, hidden in Unreal when we use smooth lighting. So if we were to change the lighting here to smooth instead of flat, it should, you know, look more like a weird beveled edges cube, which is what we want. So that's everything we needed to do in Blender to get the effect we want in Unreal. So we don't even need to set this smooth or flat. That's not going to have any effect. That's just in the Blender editor. So now we just need to export this file as an FBX so that we can import it in Unreal, and then save it, call it whatever you want, save it wherever you want. I called it Cube Sphere, but I already did this, so I'm not going to save it now, but just save it somewhere, and then go back to Unreal, and when you navigate, I guess, to wherever you want to import it, I imported it in my static meshes folder that we created earlier, and then just select import, and I already imported the cube sphere, so I'm not going to do this again, but I will show you the options you need to change. So choose to import it, and I'll just say yes, even though oh great, well maybe I will just delete this and re-import it if I can, and I cannot, so I will instead import this one, and I'm not going to actually go through with the import because I already have this, but so once you click import, you need to change it to a skeletal mesh, even though it's not a skeletal mesh. Obviously it's not a character with limbs or anything, but we need to do that anyway so that we can get the morph targets. So choose skeletal mesh, just leave this as none. I think it was just none, and it'll make one automatically, which we're not really going to mess with, but make sure this is probably going to be deselected by default, so select import morph targets. And so those are the only two changes we need to make: skeletal mesh, import morph targets, and you can leave everything else as default, and then just click import, and then when you do that you should get 4 new items in your content browser, and save everything, and then go to the cube, whatever the skeletal mesh that you just imported is called. Select that and open it up, and then you should hopefully see the morph target, the shape keys that we made in Blender are now morph targets in Unreal that we can use to morph our shape between the two shapes that we made in Blender. So by default we'll leave it as the normal sphere, on cube rather, and then when we highlight our cube we will turn it into this somewhat rounded shaped cube. We'll see how that looks, but I think this will be good for the highlighted cubes so that they'll have a more metallic appearance when we give them that material, hopefully. So we can see what that looks like by just applying the material here, the block color 0 highlighted instance. Once the shaders compile, hopefully we'll get a nice look to this. It's going to have to do some heavy lifting for once. It's no longer just a 6-faced cube. It's got something like 600 faces now, or 700, or twice as much as that actually. But now it has a bit of shape to it. Maybe that's a bit more visually interesting. It's not a very polished shape, but we can see what that looks like in the world space by bringing in one of these objects, and you can see that it's catching the light perhaps a bit more than this cube is, even though they have the same material on them, just because it actually has faces that are rounded and catching the light at different angles. So that should hopefully give it a more metallic look. If we move the point light around, you can just see that this front face is catching the light from multiple angles, and therefore seems to be more reflective than this cube, which just has the one face. That's enough babbling about that. If you don't want to follow along with this and don't want to mess with Blender and import this cube, it doesn't really matter. You can differentiate the highlighted blocks by just making them some third color like green. Anything would get the point across without having to worry about new meshes. So that's up to you. I'll carry on with this for now and see if it works out. And if not, I might just go back to highlighting them with green instead anyway, but we'll see. So now we have our weird cube sphere mesh, but the problem is it is a skeletal mesh. So if we want to use this for our blocks, we're going to need to add a skeletal mesh component and have that initially empty, and then add in the cube sphere mesh when we want to have that be the active mesh and hide this static mesh. we can just add a skeletal mesh component and put it at the same level as the block mesh by attaching it like so. And it'll be initially empty. We can even maybe add this at runtime, but let's not worry about that. Let's leave it here for now. I don't think there'll be any issues if it's just there, not doing anything. And then when we go to the highlighted state, we set our state, and then we set the skeletal mesh on this to our cube sphere, the only one we have in the project. And we also need to hide the block mesh, which we can do by set visibility for the block mesh to be hidden. And then this will now need to change too. The material on the skeletal mesh, we'll want to default that to the matched value so that it changes color from matched to highlighted. So let's go back to here and just set the default material to, well, it's going to depend on which color it is, color 0 or color 1, so we'll have to add that logic in here too. Just like how we initialized the color originally, like this, we need to do the same stuff for the skeletal mesh. I think actually we don't need to copy this logic. We can just use the material instance we already have, which has been changed to matched already. So the current value of the dynamic material that we're using should be already the highlighted, or the matched version. So here we just need to set the material on the skeletal mesh to our current material. Then we hide the static mesh, and then this now needs to change the same material. That's still fine. Set it to one of these two. That's still fine. All we're doing is updating the material, and that's now on the skeletal mesh, so that should be fine. But I think the skeletal mesh is going to still be cube shaped, because by default the morph target is probably going to be 0. So first of all, let's see what happens. It's probably just going to totally break. Also, let's destroy these. We don't need them. The point light there is probably not in the right location, but for now we're just going to see what happens. So we have our match, and then when they get highlighted, what's going to happen? They get really big because we haven't messed with the scaling, because they're from Blender instead of the default Unreal objects. But and they're shimmering strangely, probably just because it's overlap, and that's Z fighting. Yeah, they're at the same exact, Y and Z locations, and so there's some fighting between the order of which one should be on top. So that's going to be fixed when they're no longer so big. So we're going to just have to kind of wing it with the scale. So can we modify this in real time? We can. It looks like 0.5 is going to be basically what we want. Maybe 0.55, because we still want them to be bigger than unmatched tiles, but we don't want them to overlap too much. 0.52. Let's go with 0.52. So we need to go to the block, set the scale of the skeletal mesh to like 5.2. I don't think that's going to be perfect, but and now we will try to get the morph targets and change those over time. So let's see what happens if we do that. So we no longer need to change the scale when we're going from matched to highlighted, because we have the new cube shape and it's going to be the right scale from the get-go. We're just going to change the shape of it. So we can probably just, we should have changed these values anyway because we're no longer unmatched to matched. It's going to be different things. But we could probably remove the scaling here. And instead of scaling, we're going to change the morph targets for the skeletal mesh. Now I just need to get the right name for the morph target, and I believe I called it sphere key, but let's see what it's called in Unreal. Sphere key is the morph target name, and when it's 1, it has that final shape we want, or something close to what we want. That's what we got. So when it's 0, it's basically a perfect cube, and then we want to go from 0 to 1 over time, so it goes from the previous shape to the new shape. So let's do that. Sphere key is the name we'll be using here. Make sure you capitalize it and spell it correctly. And the value it's going to take is this interpolation value, which just goes from 0 to 1. And if you want to verify that, just double click the timeline. That's what we added to when we set it up previously. Pull this out so I can avoid crossing the wires. And we'll see how that works. Now the scale is not going to be perfect, so there's going to be a sudden jump in size of the highlighted cubes, so we'll have to work around that. I'm going to eject and get closer to the cubes so I can just see what happens. I'm also going to frame skip just to gradually watch the transition. So you can see them taking shape now. And that's kind of a cool effect, but we should see what it looks like in real time from the player's perspective. Highlighted cubes, which are a dark gray right now, not very highlighted, but they have that specular shine like the moment they get created as they're deforming, but then the shine no longer flickers once it's reached its final shape. Oh, that's strange. Those are a different shade of gray. We should probably add a light importance volume, light mass importance volume. I'm going to go ahead and move this back into position just so I can size this appropriately. The whole point of a light mass importance volume is to pick a subset of your world that the light should be more intricate within. But, I mean, our whole world is this one small area, so it's fine. And we could work on some post-processing to perhaps alleviate some of the issues we're having with lighting. Let's see what kind of lights we can add here. Just a skylight we can try to add to the scene. And let's see what this does, if anything, to the reflective metallic surfaces. Not a whole lot, apparently. You can see they seem to catch light more from the bottom, but when we're up here, they appear much darker. You know, that might have to do with orthographic projection, now that I think about it. Because if you watch how it appears right now, and then when I eject, it looks a lot different. So I think that's actually just based on my position and orientation of the camera. So that's one thing we can prevent from happening by going here, then go to, is it? I think it's here. Oh no, it's here. I think in Show, Post-Processing, turn off eye adaptation. Then we shouldn't see that in the scene, but when the game is playing, we need to reduce or eliminate that eye adaptation effect, which it makes it hard to tweak the lighting when it's constantly changing by some weird metrics based on the camera position. So I'm going to add a post-processing volume and just put that anywhere. It doesn't really matter because I'm going to check the unbound setting so that it is infinite extends, so it fills the entire world. And then I'm going to go to pull this out a little bit. Post-process, let's see, I think it's under exposure. So it's called exposure in some places, and it's also called eye adaptation. I believe that is the same effect. But we want to set both of these to 1 so that it will never change, or if it does change, it doesn't actually change anything. And now, lighting should be a little more static, which is actually a positive in this case because we want to, get the lighting good from one angle before we worry about all angles. So now we pause and eject, and hopefully that weird effect of moving the camera, changing the intensity of the light, is no longer present. So now we just need to figure out why they still look so flat instead of reflective. And it's probably because our point light is like up here. If we look for where the point light is, it's like up and to the left. If we perhaps move it to be somewhere, we can't move it in the middle of the game, but if we so we're trying to move it while the game was running, which caused an error or a warning. Perhaps if we move the light source somewhere closer to the camera but offset slightly, that will give us a more obvious metallic sheen on those, like a specular point on those metallic surfaces. Might need to rebuild the lighting, we'll see. You see this sheen is what I'm talking about here. Like I want that to be kind of spread out across more of the shape, so I might actually want less that's kind of the idea of what I wanted. I want the light to look like that, like it's shining off of the metallic surfaces, but perhaps less specular, a little bit rougher. But I do want this to happen, so I think I need to change from orthographic to a very low field of view. What we want to do is have the benefits of perspective projection so that you can see the lighting effects more clearly without the drawbacks of perspective with the fisheye lens type of thing. So if we decrease the field of view and pull the camera back, we should have a somewhat similar effect to orthographic projection without the drawbacks of having zero depth. Now I'm not sure why we're not seeing the test grid in the camera's preview lens. Perhaps because I set it to be hidden during gameplay. I think that's what I did, so I'm going to uncheck that, and now we should see it in the camera, because the camera sees what the gameplay will look like. Camera actor can now see the grid, and that's just really helpful for pulling it back appropriately. So maybe that's about what we want. Also, you probably noticed when we were in orthographic projection, like the middle column here and like one of the rows here appeared thinner than the other grid lines, which was really weird, because I thought since it was orthographic there would be no issues with perspective like that, but this actually seems a little better, though there will be some slight weirdness with movement sometimes in perspective mode. You see the player's blocks seem to kind of jump in all over the place. I don't know why that's happening in perspective but not in orthographic. It's a little strange. Also, now the lighting looks completely different, and it's really hard to tell the difference between orange and silver in this lighting because everything is so blown out. So we'll have to change that, obviously. But I want to see what the metallics ones look like now. That's a little better. Okay, this is very strange. The orange blocks, when they get shiny, are shiny like that. But then when these blocks are matched, they appear almost matte, like you're not getting any of that specular shine. So I don't know why that's happening. The material on this guy is material instance dynamic. This is also material instance dynamic, right? Yeah. And in the preview image it looks the same. It's got that specular reflection thing. Actually, I want to change the roughness to like 0.1, I think. And specular maybe like 0.3. That's not going to have much of an effect. It's the metallic that does the majority of that. So let's lower these to something a little more reasonable. And maybe increase the emissiveness slightly, so it's brighter. 0.3, and then rougher, so it's not quite so mirror-like. 3723. So we save those materials. Let's save all. The silver colored blocks are not becoming the proper color here. They're not becoming this color. They're becoming some like dead gray color. That's totally matte. So that is strange indeed. So I still haven't been able to work out why the highlighted material was working for one of the two block colors but not the other one. So what I've done to alleviate that for now is, for some reason it's block color 0 that works and block color 1 that wasn't working. So for the become highlighted function I just set both of these to 0 regardless of whether it's color 1 or color 0. They both get block color 0 matched inst as the new starting dynamic color. And then in the event graph here I just set them both to color 0 highlighted, whether it's color 0 or color 1. So for now, at least they'll both get the same metallic color, and we'll just worry about that never, or maybe later. But for now, at least we'll get the color working properly. We still need to refine the lighting here because it's just a bit too blown out still, I think. So that emissive light's probably too bright. And the silver, the metallic color looks alright, I think now. It's not perfect, but it's better than nothing, I think. So for the emissive colors here, that just needs to be toned down a little bit, I think. Let's try like 10 instead of 30. For both this one and this one. That looks a bit too yellow maybe, but we'll see. Looks pretty much the same, honestly. Probably better though, less bleeding between colors. That weird shimmering that happens when you move left and right is pretty distracting. I feel like that's not what we want to have happen. You see what I'm talking about, right? This like phasing in and out of existence as it jumps from lane to lane there. That's pretty weird. It wasn't happening in orthographic projection, but let's actually verify that. Let's go back to orthographic for now and see if that is okay now, maybe, or if it still looks bad. You see that phasing in and out of existence doesn't happen anymore. And the colors look okay here, I think. We'll see how the silver looks. You know, that's probably fine, actually. That seems pretty good. Maybe we'll stay orthographic, because we won't have to figure out what's going on with that weird phasing movement, which I think is more distracting than the glare effects with the... Yeah, actually, that looks pretty good. Pretty okay, I would say. So, good. We're going to stay in orthographic. And I'm going to... I can now move the camera closer if I want to. Let's do 600. 1000. 1000, please. 2000. Let's just have fun. There we go. 2000. It still look identical to before because it's orthographic. Okay. The only thing that might be affected is the glare from the metallic materials, but it looks fine. Okay. So now we want to just move on to the next. Let's stop worrying about the graphics so much for now and move on to getting the blocks to clear when the timer bar reaches the right hand side, and then when they clear we need the blocks above them to fall down and recalibrate themselves, create new matches potentially.